Well, good morning. Of course, it may not be morning when you're doing it. You may be doing this in the afternoon. And if that's the case, then I guess that would say good afternoon. But nonetheless, for me, while I'm recording this for you, it is good morning. So we're going to go ahead and start a new chapter, chapter 13. This is lesson 1, chapter 13:1. And there is a worksheet for this activity. But the worksheet, there's not anything, really this lesson is mainly just reading and taking down a few notes, learning a few words. So you might want to have somewhere, if you're keeping some sort of math notes, whether it's on little note cards or on a paper or whatever, you might want to have that close by because you might want to draw a couple of pictures or write down a few things to help you remember. The worksheet that goes with today, worksheet 13:1, it's all, the whole thing, front and back, is just skill sharpening. It's just stuff that you've learned. There's not a new skill to learn today. That'll come tomorrow. So basically, let's look at the first page, talking about geometry, telling us what the word geometry means. If you break up the word geometry, geo means earth, and then metron means measure. I'm going to go as far out to say as I'm pretty certain that is Latin, I would be assured. Anyway, so geometry actually means earth measure. But it's used to survey land, build maps, draw blueprints, design airplanes, and so much more. So as we study this branch of mathematics, you're going to be using a whole lot of the skills that you've learned so far, and you'll be learning a few new skills to go along with it. So we're going to go ahead and start in on that. So look at those pictures at the bottom of that page. I don't know what page it is, 253. Got the Great Pyramid of Giza in Egypt, built approximately 2560 BC. And you have the plan of the city of Washington in March 1792. So you see how geometry, quote unquote, was used for that. All right, a little history. Since the beginning of time, men have used math to measure the earth. Cities were built. Of course, Cain built a city. Genesis 4:17, he had a child named Enoch, and he made the name of that city was Enoch after his son. Pyramids have been built. Other building projects, Tower of Babel. So, a lot of times you'll hear, oh, the cavemen days, the cavemen were so dumb. No, there weren't cavemen unless you're talking about David and his men when they were hiding in the caves from King Saul, but they were far from dumb. They were quite smart, actually. Anyway, so the Greek mathematicians, however, the ones who formalized geometry, somewhere around 300 BC, the Greek mathematician Euclid compiled the Elements, a work which taught the current Greek understanding of geometry. To this day, the essence of what is taught in high school geometry is based on Euclid's Elements. And there's a painting of Euclid, circa 1474. Sadly, though, the Greeks had little interest in using geometry to measure the earth. As we'll explore in more depth later in this chapter, they pursued geometry mainly as an intellectual and even religious pursuit, rather than a useful tool. In this course, we'll be looking at the big picture of exploring the shapes around us and using shapes to describe God's creation. We'll see how geometry helps us measure the earth, so that when you do an official geometry course later on, maybe if you go to college or whatever, if you decide to, you'll understand how to apply it outside a textbook. We'll also discover evidences of God's wisdom and care as we go, as we have when studying other concepts. So take a look at that honeycomb. You notice that each of those cells has a shape. Now, wherever you are sitting, look around the room. Everywhere you look, there are shapes. If you're sitting at a table, chair, there's a window probably beside you, a door. Obviously, you've got books in front of you. There's a doorknob. Everything you see has a shape and a size. How do we describe these shapes and sizes mathematically? In order to describe shapes mathematically, we have to start somewhere. In geometry, we start with undefined terms. Now that's a bolded word that you might want to write down. And the definition is terms that can be described but can't be defined with other already defined terms. So we'll look at 3 undefined terms. So you want to know what that is. Now here are 3 undefined terms if you'll look on 255. Points, lines, and planes. Those are 3 undefined terms. They can be described, but they can't be defined with other terms that have been defined already. We can build our understanding of shapes using these terms as launching pads. So we'll start with what we call points. A point refers to an exact location. We represent it with a dot. Even though a dot takes up space and a point technically doesn't, it's just a location. The usefulness of defining a point is an exact location. It's not to deny the width of the points we draw. It's to make it so we can measure. We can take measurements, draw objects, learn about objects without taking into account the width of the marks that we make on the paper. So basically, you just want to write the word on your paper or wherever you have. You'll just want to write what a point is. And remember, this is an undefined term. You can put that over here. Make a little note. Undefined term. I'm not going to finish writing it. And then underneath point, just show me what it is. And I know you're like, well, that's dumb. I know what that is. Well, later on, this will be very important. So you might want to write that down. Okay, and then we have lines. Mathematical lines. They don't have any width. That way, it doesn't matter if we draw a line thick or thin. Euclid described it as breathless length. In other words, it can be thought of as a length extending indefinitely in both directions, which you can show with arrows. So on another piece of paper or another note card or whatever, you'll want to draw this. Make sure that you put your arrows, and this is what we call in mathematics a line. Now, the reason that you have to have the arrows is to show that it keeps going in both directions eternally, forever. All right. Now, of course, physical lines don't really go on indefinitely, but this description makes it so when working with shapes, we can extend lines as we need to. We'll later use this concept to help find information, such as the height of a tree. Now, this is right in the middle of your paper on page 255, where it says note. Technically, we call portions of a line segment, but in this course, we won't be distinguishing between the two. So in times past, I've taught that this would be a line, but this, where it has a stopping and a starting point, would be a line segment. Basically, it would be a part of a line, just, that had a definite start and a definite stop. But it says in this book, we won't be using line segments, just lines. While lines could technically be curved in Euclidean geometry, when you hear the word line, you can assume a straight line is meant. Okay, in a mathematical sense, we can think of points and lines as lying in what we call planes, or flat, boundless sections of space with a length and a width but no depth. A more technical definition of a plane is a flat surface on which a straight line joining any 2 points on it would wholly lie. By flat surface, we don't necessarily mean a surface we can see. We can think of each side of a toaster oven as lying in a different plane. If you were to lay a large flat surface on top of each side, you could extend that surface indefinitely. So a plane is just your section of where you're, to put it in normal terms, I guess you could say a plane would be a section where a point lies, or where what do you call it? What am I trying to say? I guess where 2 points lie, or where a shape lies. I guess you could call this whole screen a plane. It's just the section where what we're looking at, basically. Okay, so you see the toaster oven. So why do we need planes? I'm glad you asked. Planes help us break down three-dimensional, or in short 3D space, into multiple two-dimensional or 2D spaces. The toaster, for example, is a 3D figure that has 6 two-dimensional figures: the front, back, top, bottom, left side, right side. Okay, I think you should understand the difference between 2D and 3D. If you don't, look at the next page at the very top. It shows you. So that box where it says entire toaster oven, it's 3D. The front of the toaster oven is 2D. Now, a good way that I always say you can know 3D and 2D, 2D is just like a flat plane. There's no dimension to it. It's just flat. Like the top of a desk is just 2D, two-dimensional. But if you were to pick up the whole box or the whole toaster oven or the whole shebang, we're talking 3D. It's got all the sides to it. It's got flat sides and points and, sides and angles and yada yada. We often look at objects as two-dimensional shapes, dealing with one plane or one surface at a time. For example, we could look at one side of a quartz crystal at a time. That'd be a 2D shape. Or you could look at the entire crystal as a 3D shape. So I hope that makes sense to you. It's real simple. Okay, keeping perspective, the undefined terms that we just looked at for points, lines, and planes are the terms typically taught and used. They're part of the geometry system referred to as Euclidean geometry, the geometry based on Euclid's elements. However, other geometry systems exist based on using different descriptions for these terms. For example, in spherical geometry, a line is described as a great circle, which is quite different from the description we looked at today. Yet spherical geometry, like Euclidean geometry, proves quite useful in describing God's creation too. The equator, for example, can be thought of as a line in spherical geometry. Non-Euclidean geometry is not something you'll be expected to learn. However, it's important to know that other definitions in geometry systems exist. The existence of other systems reminds us that each one is a tool, a way of describing God's universe, which is so complex we need multiple geometries to explore it. And even all that won't tell us everything. There's still the mysteries of God that we'll never know. Maybe one day. Okay, your assignment then. Make sure you've written down those things. If you want to do that 3D, and you may already know how to do it. If you know how to draw a 3D object, that's great. If not, you'll draw a 2D flat shape, like a rectangle. Okay, now to make it 3D, if you know how to do this, then you don't have to watch. You can turn it off. Now see, notice this now becomes 3D. So you might want to mark that down on a piece of paper or wherever you're keeping notes if you are 3D, three-dimensional, whatever. And then you'd want to have something like this to show 2D so that you can kind of see it and understand. Okay? All right, your assignment is worksheet 13.1. I'm going to grade it. It's all just, mostly it's all just skill sharpening. So if you need any help, let me know. Otherwise, that's all for today.